So in this video, we're going to write the equation of a parabola that's centered at 0, 0, given the focus and directrix, and then we're going to do the same thing in reverse. We're going to find the focus and directrix of a parabola that's centered at 0, 0 when we are given the equation. So in order to write the equation of standard parabolas using the vertex and directrix, we have to understand something very special about the relationships between the equation, the focus, and the directrix. So in the previous video, we talked about how there's this very important distance p between the focus and the vertex and the focus and the directrix. Remember, it's the same exact distance. And currently, we're focusing on everything being centered at 0, 0. And so that makes it a little bit easier for us to see. So when something is centered at 0, 0, what you're going to notice is that that distance p helps us to find our focus and directrix, because p itself is the y-coordinate of our focus, and the opposite of p is our directrix. So we're going to be using that to help us write the equation, because if you look very closely here, our equation uses that p value. So that coefficient of x squared, which you can see right here, deals with 1 over 4p. So if we can find this distance p, we can actually write the equation for any parabola if we just know the focus and the directrix. So that's what we're going to be focusing on the next slide. So in these two examples, we're going to write the equation of a parabola with a vertex at 0, 0 with the given focus and directrix. So for each example, I'm going to start by drawing out a little sketch. So here I have my little sketch. I have my focus at 0, 3. I then have a directrix at y equals -3. So there's a horizontal line at y equals -3. So just from looking at this, I know that I'm centered at 0, 0, and I'm going to open up because I need to be opening up around that focus. So to start writing my equation, I need to refer back to the previous slide. I need to focus on that value p. So remember, the equation is formed by taking y equals 1 over 4p times the x squared. And remember that p value is the distance between the vertex and the focus and the vertex and the directrix. So here we can see that we have a p value of 1, 2, 3 and a p value of 1, 2, 3. So now I'm going to take that p value and I'm going to replace it with 3. So I really have 1 over 4 times 3, which in this case is going to become 1 over 12x squared. So there's my equation. So now let's look at example 2. So down here, here's example 2. We have a focus at 0, -1, 2, 3, 4, 5, and my directrix is going up to 5 as well. So there's my focus, there's my directrix, so I can see both pieces. My vertex is at 0, 0 as the instructions state, and then my graph has to open up down so that it goes around the focus. So here I already know that my p value is going to be negative because my graph is opening down. So keep that in mind. Now my p value, remember, is the distance between the vertex and the directrix and the focus. So here you can see it's -5 because it's upside down, -5 because it is upside down. So we're going to go over to our equation. So we have y equals 1 over 4p times x squared. So we have y equals 1 over 4 times -5 with the x squared. So this becomes y equals a -1/20 x squared. So now we're going to do that same concept, but in reverse. So here we're going to identify the focus and the directrix for the given parabola. So as you can see here, we have y equals 2x squared. Now remember, typically this equation is y equals 1 over 4p x squared. So what this equation is really telling us is that 1 over 4p is equal to 2. So in order to find our focus and our directrix, we need to find our p value. Now this might seem like it's really complicated to do, but we can actually go back to Algebra 1 and use the concept of a cross product to help us solve for p here. So what I like to do is put 2 over 1, because 2 can really be written as the fraction 2 over 1. And then here, because I have fraction equals fraction, I can actually cross multiply. So I have 1 times 1 equals 4p times 2. So I have 1 equals, this becomes 8p. And in order to find the value for p, all I have to do is divide by 8. So I find that my p value here is equal to 1/8. So this value right here is the distance between my vertex and its focus and its directrix. So what I can do now to find what my focus and directrix would be is I can draw a little sketch, and I can say, well, I know my vertex is at 0, 0, so I will put that there. I then know that my graph is opening up because this value here is positive. So I'm going to sketch that in there. And then from here, I know that the distance between my vertex and its focus and vertex and directrix is 1/8. So I know that I'm going up 1/8 to the y value. So my focus here is going to be x is 0, y is 1/8 because I go up 1/8. And then my directrix is going to be y is equal to, I go down 1/8. So y is equal to a negative 1/8. So we can use the equation that we've been given to identify our focus and our directrix. So let's repeat this one more time. So here we can see that we have a value out in front of our x squared of negative 3/4. So that is saying that 1 over 4p is equal to, I'm going to put the negative in the numerator, so a negative 3/4. So that's what that's telling us, because the coefficient of x squared is equal to 1 over 4p. So what we can do here, again, is we can cross multiply. So I get 1 times 4, which is 4, is equal to 4p times negative 3, which is negative 12p. So then what I can do here is I can divide by a negative 12, and I find a p-value that's equal to 4 over negative 12, which then simplifies down to a negative 1/3. So my p-value here is a negative 1/3. So that's telling me a couple of things. First, it's telling me that the distance between my vertex and the focus and the directrix is going to be 1/3. It's also telling me that my graph opens up downwards because of that negative out in front. So the negative tells us that we're opening down. So now from here, all I need to do is find my focus and my directrix. I know my focus goes inside here, and I know that it's moving down a distance of 1/3. So this went to x is 0, y is negative 1/3. And my directrix goes up and forms a line here at y equals a positive 1/3. So again, while we have fractions, we still can determine both our focus and our directrix by being given that equation.